This is vector 6. We're the last kind of part of this unit, this chapter, before we do the mixed exercise, and this is looking at vectors in context. Key things here, we're going to go through a couple of definitions that are important to know and then have a look at a couple of examples. Now, when we start applying vectors to a context and looking at physical properties representing them with vectors, we need to be aware that there's some linguistic ways in which we define something as a vector or a scalar. Now, a key indication of this is if I want to define a vector quantity, say let's talk about velocity. So velocity will always be a vector. It will always have a magnitude and a direction. And like this one, so this velocity of 5i plus 9j meters per second. Now, an equivalent scalar quantity for velocity is speed, but speed does not have a direction. We've looked at converting vectors to scalars before, and the way we do this is we just want to find the magnitude of the vector. So if you're ever asked to go from a velocity to a speed, all you need to do is find the magnitude of that velocity. Okay, so velocity is 5i plus 9j, and that means the speed is the magnitude of that, which is the root of 106. Another kind of vector quantity, something which is specifically a vector quantity, is displacement. Now, displacement is how far something is away from an origin, right? So displacement is a position vector at a given time. We'll look more at displacement as we go further into looking at using speed as in time and calculating kind of forces and things as well, and further on into the mechanics part of the course. But displacement will be a position vector at a given time. So this could be the displacement 2i minus 4j. Now, if I want to find the distance from the origin that thing is, when the displacement is 2i minus 4j, again, I just need to find the magnitude of that vector. Okay. Now that will be the distance from the origin, because displacement is a position vector, so it goes from the origin. Okay. So we need to be able to do that. We need to know how to find an equivalent scalar quantity of a vector quantity. So if we've got a vector and we want to make it into a scalar, we need to find the magnitude. Simple as that. We also want to sometimes be given some questions with a bit of context. So if we've got, let's say, this question, we've got an initial velocity of a boat be u, which equals 6i minus 5j meters per second, and we want the acceleration of that boat to be a equals 3i plus 7j meters per second. It says, given that the final velocity is given by the equation v equals u plus at, we want to calculate the final velocity after 5 seconds. So v is the final velocity, and we want to apply this equation to our vectors. Now, initially we might think, oh, that's quite difficult, but we've done something like this before. It is very, very simple. I've got my equation v equals u plus at, and this is one we'll revisit when we start doing the Suvat equations, the kinematics equations. But v equals u plus at. I know what u is, I know what a is, and I know what t is. Okay, I know that u is 6i minus 5j. I know that t is my time, so it's 5 seconds. Okay, so I'm going to put a 5 here, and this is just put the number before the bracket by convention, but 5 lots of the acceleration, which is 3i plus 7j. Now I'm going to convert them into column vectors, because I know that makes it easier, and then I can just solve it. Okay, and it gives me v equals 21 over 30. And as normal, I'm going to give my answer in the form it was asked, so 21i plus 30j, and it's meters per second for velocity. Okay, so sometimes we'll have to apply a formula, which we might initially go, oh, I don't know how to do this. Might start trying to find magnitudes and sub it in. You don't need to bother. Okay, you can substitute straight into that equation and work with that equation, as long as you're given bolded variables, which will be the vectors. Look at one more question, just to remind us of something, but these are the actual maths of this we've done before. It's just the context which is new. We've got a particle is under the influence of two forces, F1 and F2, where F1 is negative 2i plus 3j, and F2 is negative 6i minus 7j. Now we want to calculate the angle between R, which is the resultant force acting on the particle, and the vector I plus j. Okay. So we want to find a way of us finding the resultant force, R. Now, we should remember the resultant force is simply the two forces added together. Okay, resultant force is where we add the two things together. So I've got F1 plus F2 gives me the resultant force, and I can go ahead and do that. I've got negative 2, 3 plus negative 6, negative 7. And that gives me this vector, negative 8, negative 4, which is negative 8i minus 4j. And at this point, we want to find an angle between this vector r and a vector I plus j. The key thing here is I need a diagram now. Okay, I have to have a diagram. So let's draw my vector r. So -8, -4. Okay, in general. And I also want a sense of where my vector I plus j is. So I'm going to put that on there. Now this is difficult. This is a slightly more difficult question, but I'm always going to start using my trigonometry because that is the key way I can start finding an angle, right? So if I draw this here, I know I've got 3 angles I can find. I've got this angle above the horizontal, I've got a nice right angle here, and I've got this angle that I can find using my trigonometry. I also know that this is going to be 90 degrees, yeah? So I've got x, y, and 90 degrees. Now, sometimes finding y might be a little bit difficult, but I've got I plus j. That means I'm going 1 along and 1 up. I should be able to say straight away that y is 45 degrees. Okay, that should be quite easy for me to see. And now my challenge is to find x. So I've got x where the opposite is 8, okay, and the adjacent is 4. So the tan of x is 8 over 4. The inverse tangent of x, or the inverse tangent of 2, will give me x, and that gives me 63.4 degrees. Okay? So I've got x and I've got y. To find this total angle, all I need to do is add them together, 198.4 degrees. Now there's a couple of things here. It can get quite difficult to define which way is clockwise. I've said that r is 198.4 degrees clockwise of the vector I plus j. Okay, if I go clockwise from I plus j, I get to the vector r. The issue is I can also go clockwise here, and so this can be difficult. The key way to get the marks is the diagram. Okay, so this is true, but I will get my marks as long as I've shown on my diagram which angle I'm finding. Okay, so drawing the diagram as well as making this question significantly easier will also get you marks in the exam if you're asked to do something like this. Okay, so what I'd like to always see is a really clear diagram marking the angles and then showing me the calculation you've done to get them.